Hey everyone, welcome to the November edition of Make Live. We're starting a little bit later than we normally do this month because we are working on a really massive project. In fact, it's so massive that we already kind of built it just to kind of make things easy. My name is Tyler Weingartner. I'm the video producer here at Make Magazine. I am joined today by Jillian Ogle from Let's Robot TV.
Hello.
And this is a project that we're working on together. Again, I've kind of built the hardware already for this robot arm. This is the Moveo robot arm, which is an open source 3D printed robot arm designed by BCN 3D. And what we're going to be doing on the live stream today is that we are going to be we're going to be setting up the way it was originally intended, which is to be driven through a laptop connected to it through a 3D printer interface software called Pronterface, which I think is one of my favorite software names ever. But then next month, we're going to be doing something really special.
Oh, yeah.
Yeah.
So if you guys aren't familiar with my site, letsrobot.tv, we're making an open telerobotics platform that's kind of like Twitch for robots. So it actually allows users to go on our site and control various robots online. Anybody can add a robot to our platform. Most of them run on Raspberry Pis, and you can download our open source software and get going. We have an awesome community of people that hang out on robots and like to help other people get robots connected, and it's a lot of fun.
Yeah.
Yeah.
And there's a couple of robots that you can see. If you go to Let's Robot TV, you can see some of the different types of robots that you can drive around. In fact, one of them is running around our office right now that you can take control of.
We got Dash live right now.
Yeah.
It's a robot named Dash, Dash Cam.
Yeah. And a lot of times they end up being, sort of like little car robot things that you can drive around and heckle us across the internet and talk to us, and we can talk to you. But this one's going to be a little bit different because it's going to be an arm, and people can connect all kinds of crazy robots to this platform. Like, what's the most absurd one you've seen, or some of the most absurd ones you've seen?
People have connected all kinds of stuff. So probably we've had people connect like lawnmowers, Roombas, simple four-wheeled robots, robots with grippers. If you go on right now, there's a big arcade claw machine you can use to grab stuffed animals. There is a xylophone that you can play, and and the robots can be really simple too. Like a couple people have added just a single LED that live streams and can be controlled. So it can get pretty absurd.
Yeah.
Yeah.
Anyhow, it's a lot of fun. We're looking forward to being able to connect this robot arm to the platform, so people can use it to move it around and grab things and, pick up knives and then stab me while I'm working on projects here on the next Make Live build. Maybe don't do that. Or maybe do. I don't know. We'll figure that out next month. But in the meantime, the first thing we need to do before we start getting into finishing this project is we need to thank the folks who make this series possible, which is our friends at DigiKey. DigiKey is an electronics distributor based here in the U.S. They sell nearly all the components needed for you to build this project and any other project that you need. We have a ton of electronic components here, like the stepper motors, the stepper motor drivers, the ramps board that's used is sort of the brain interface between the Arduino, which they also sell, the Raspberry Pi that we'll use, and all the way down to the discrete components like capacitors, resistors, and anything else you need to build your next electronics project. They sell and they ship fast, and they're wonderful people to work with. They come out to every maker fair. They love working with makers to see what kind of projects they're working on, and they're fun to work with to make series like this possible. So thank you again to DigiKey for letting us get away with this kind of nonsense, because we probably couldn't do it otherwise. But in the meantime, the first thing I need to do is finish. For this thing, we'll kind of take a little bit of a tour here.
So what have we done already?
We've done a lot. So there's a ton of 3D printing, as you can probably see. I think I started doing the 3D printing for this project back in September. Might have been some of the earliest parts we 3D printed.
And all the parts are online?
They are. You can find the parts like you would think normally on Thingiverse. However, what I really recommend following for finding the components is you go to the GitHub repo for the project. And if you look in the description for this video, whether you're watching on YouTube or on Facebook, go look in the description. I've put a link to the GitHub repo there. That's where you find the most complete collection of all the parts that you need for this project. You'll need a fairly sizable printer to print a couple of the parts, but everything else here was pretty much printed on like an Ultimaker 2 or a Prusa size printer. The two biggest parts here are this base part right here, so we can get a little bit of a closer look at it, which sounds ridiculous because it's the big part, but well, that's where we're at. What am I looking at here?
Got the zoom camera.
So you have this massive part here. This part was printed by our friend and senior editor of Make Magazine, Caleb Kraft, on his Taz 5, 6. Anyhow, much larger format printer. And then he also printed up this part here, which you can't see because I have it pointed at the wrong camera. This part here, which is, well, we might, if we get that far, we'll be using this to enclose all of our electronics. But for the sake of today, we might just be leaving everything exposed. We'll see how far we get. But anyhow, this part also needed to be printed on a larger printer. So we needed some help with that one. But anyhow, then mounted all of the motors and set up these belts. And I'm sorry, you had a question?
Oh, I was going to say, how many motors do we have here? So there's two at the base?
I think how many motors are there total? There's this one which controls I'm going to try to remember what all these different rotations are. Well, this is our kind of overall z-axis rotation. Speaking of z-axis as in vertical z-axis. I'm not one of those weird Y vertical axis people.
Is this basically the Z right here?
I was talking about the rotation in this direction.
Okay. Oh, that's this motor down over here.
So this eventually will be mounted onto this turntable here, and then it'll rotate, and then after being driven by this motor right here. So this will be kind of offset and drive this belt, which will then be eventually set up correctly. But as I've placed it here, it is not. Then we have two more motors, these the big NEMA 23s that are controlling this this rotation here, the lower part of the articulation. Another stepper that's up here, and that is controlling that rotation there. There is another one housed within this body part here that controls, probably getting out of what people can see, this rotation here. And then there's another motor that's encased in here that controls this articulation. And then finally we have this servo motor here that controls the action of the gripper.
That's pretty cool.
So that is all the articulation points of this, the Moveo open source robot arm. It uses these T5 timing belts. It's got these, let's see if we can get a camera in there. Uses all these little tensioner parts in here. Let's see if you can. So those provide tension for the belts to keep them tensioned, for lack of a better phrase, and just keep everything running smoothly. And again, just about every part here is 3D printed, except for a whole bunch of like bearings and pulleys and things that came from McMaster-Carr, and of course all the electronic components that came from DigiKey. So anyhow, there's still a ton of manual work to be done. Try and move this around so I'm not sitting on top of the belt here. So I've got to drive a bunch of M4 bolts into this guy here, which is our base. And do that again so people can see what I just did. This part here, which is our base part, that's going to mount to our plywood baseboard here. So I'm just going to do the work of screwing those into place, and then mount them to the board here, and then mount this also to this bottom part here, and then mount this part. So got a little bit of work ahead. And then we'll start connecting the electronics. And of course, while we're doing this, if you have any questions, just pop them into the chat, and we will do our best to catch up with them and answer them.
All right.
Although anything that's robotics specific, I'll of course be punting to Jill here, because I don't really know anything about robots other than building them is time consuming. That's what I know about robots right now.
Oh my. Let's see. Cybergoose Jr. says hello.
Hello.
Hi. Let's see. We got Matt Cove Driveway Workshop with Jim Bashirs. So when will you install the safety cage and write your lockout tagout procedures? Wow.
That sounds like good ideas. We should probably do that sometime after we connect it to the internet. I'm not sure of the power of these stepper motors to know if they actually present a significant health risk. We'll find out. Oh. Especially once it starts, once we connect it to the internet and it can do things like grab knives.
Let's see. That's not too much. Doesn't feel like it has a whole lot of torque. But I could be wrong. I don't use steppers that much.
I don't either. Well, I've used them a little bit. This is a really noisy process.
That's how you know it's noisy.
That's how we know it's working.
Oh man. Trust me, I'm an engineer. When will you arm this with a sword?
We won't arm it with a sword, but you might.
Yeah. Well, we do intend to hook this arm up for internet control, so if you donate enough money to our live stream, maybe we could try a katana session.
Yeah. We
Oh, that clicking on CyberStream. Overall cost?
What is the overall cost of this? I can say it's not terribly cheap. I wish I could tell you. The electronics are a few hundred, I would say. The hardware, I mean, it was a pretty massive order that I made from McMaster-Carr for all the fasteners and the bearings and things like that. You could probably source that stuff cheaper if you are patient, which I'm not. If you order from places like, I don't know, AliExpress or Banggood, or I mean, there's lots of places to get this kind of stuff that's probably cheaper than McMaster-Carr, but I was in a bit of a hurry. And also, because with McMaster-Carr, you tend to buy in bulk, so I am going to have, bought a lot of bags of 100 counts of, M4 by 30s and things like that. The bill of materials isn't the most straightforward thing in the world. You'll also need to do a little bit of interpretation. They do have a nice PDF list that's the bill of materials, but I do recommend referencing it against the build instructions, because you'll probably find that you might be what your interpretation of like M8 by 65, you might be going with a cap screw because you think that makes sense, and then you realize, oh, that one needs to be a hex head bolt. So little things like that, caught me up a couple of times and predicated a couple of additional trips to the hardware store, things like that.
Awesome.
And of course, there's all the cost in filament for the 3D printed parts. I probably would say, and I don't know what, again, because they were printed remotely by our friend Caleb, for these really large parts, but for the parts that I printed here, I would say I probably went through 5 or 6 filament spools in total going through it. Obviously didn't go through much of the yellow for the little detail parts, but a whole lot of black PLA in here.
All right. Let's see.
So the long and the short of the discussion of price, I would say plan on spending at least $500 or $600 on this to before you're ready to start building.
Oh wow. Yeah. So, well, it's a pretty like nice and robust looking arm. So I guess I'd expect it to cost a couple more dollars than a
There's
different one.
there's one joint on there that I'm a little iffy on. Maybe I didn't assemble it quite as tidily as I could have, and it's a part that we had to make some hasty adjustments to here, and that's this joint right here, this vertical axis here, because this is just well, it's a M8 threaded rod that's coming out of a motor shaft here, and then just threaded into a lock nut that's pretty much just friction held in this 3D printed part. The fitment wasn't great on there, so I ended up using a heat gun to temporarily melt the plastic, so I can kind of reshape it and kind of moosh everything into place. That's a technical term.
I like the word moosh.
Oh, hello. There's a robot bonking into my foot.
Yes, that happens when I visit.
Yeah, and yeah. So, and also that's a good technique to know is have a heat gun handy, especially when you print things in PLA, which is nice to print with because things tend to retain their dimensional accuracy. It also means that you probably shouldn't leave this project in a hot car. Which shouldn't be too much trouble if you're in the northern hemisphere because, well, it's not cold or it's not warm as much anymore. We're heading into the winter months, but PLA will melt in the back of your car. I've seen many miserable posts of 3D printer owners that had a 3D printed 3D printer that they left in the back of their car, and on a hot day came back and they had a melty pile of aluminum extrusions.
Let's see. Roughly Animated says, "Hi, Jill." Hello. I have a couple people saying hi, hello, creative terms, Tems. Random Taters says, "Is the software open source?"
The software, in so much, and we haven't quite gotten there yet, but the software in question is, well, it's a piece of code that you install on an Arduino Mega, and from there you are using the 3D printer sort of diagnostic tool. I think that's what it's primarily used for, called Pronterface, and I believe it is open source. And the task today will be try not to giggle every time we say the name of that piece of software.
We need one of those like word counters.
Yeah.
Pronterface.
Like printer face, but an O instead.
Let's see. Could it be bad or... Wait. I'm reading too far ahead here. How are you sensing the gripper pressure on the grabbed part?
I don't think we are.
Yeah, I don't
Not
think
yet.
these are feedback servos, are they? No.
No, that's
And
just
there's no sensor on it.
that's just a dumb old servo.
So, like, the nice thing about these platforms is you can easily sort of expand on the functionality. So this is basically just a really nice, robust arm that will lift things and hold its position really well, which is useful for somebody like me. And then it's really easy. You can just take the CAD files and stuff like that and make your own changes. If you want to add pressure sensors on it, you can. Or just like a simple limit switch, which I've done in the past with other types of grippers.
All right.
I'm sure they can hear me really well.
Yeah. Sorry about all the racket over here as I've been screwing these bolts into place. This is what's going to end up securing the base to our platform here.
Nice. So, oh, is this whole wood platform for the robot?
It is.
Oh, wow.
And everything's sort of equidistant. I'm going to use these to mark out where I need to drill the holes for these bolts. And then from there, I'm going to drill the holes. And then we'll be able to mount this base part onto the platform. And then from there, we should be able to attach the the arm onto this this base here, and then we'll start feeling like we've accomplished something.
All right, accomplishment. I hope we get achievements. Trust me, I'm an engineer, says Jill. Will this be used for cooking with Jill's streams? Maybe this bot can withstand soup. Oh, man. So I actually had an incident the other day where one of my robots fell off a perch that I put them on because they were watching me make a grilled cheese sandwich. And I had soup ready to go, so I can dip my grilled cheese sandwich, but my robot fell off, hit the pan, flipped over the pan of soup, and the soup fell on the robot as the robot cracked open on the floor. It was probably the most disastrous incident I've ever had in the history of my robots. So it was completely destroyed. I don't know if this particular robot is soup-proof, but one of my childhood dreams has been for the internet to make me a sandwich, and I think this particular robot might help accomplish that.
I'd been suggesting that we could just, I don't know, because there's a couple of startups here that are exploring robotic cooking.
It's a nice breeze.
There's Beastrobot, which I don't know if they ever ended up with a successful product, but they had a sandwich making robot. And we're due to do another visit next week to Creator, which is a startup that has made a robot that makes hamburgers.
That sounds like a lot of fun.
Which is now my favorite robot in the world.
Ooh.
Because it makes hamburgers.
Joseph Floyd says, could this robot be battery operated and mounted to a remote-controlled Roomba?
I mean, well, I don't know what the load limit of a Roomba is. I suspect it's not the highest thing in the world.
Yeah, you might have some balancing issues there. Although Roombas are pretty bottom heavy and they have a pretty good low center of mass, so it wouldn't be the worst thing ever, but
wouldn't say it's impossible.
It wouldn't be the best thing ever. We've gone from clicks to creaks.
And back to clicks.
What is the size of the print bed needed for the 3D printing components?
Again, most of the parts were printed on an Ultimaker 2 and a Prusa i3 Mark II, which is, I think those are both 200 or 200 millimeter, or 200 or 250 millimeter square bed parts. There are two parts, however, that do need a larger print bed, and that's, again, the large first stage of the robot articulation arm here and the electronics enclosure, which arguably you could either fabricate your own enclosure out of wood or plastic or whatever materials you have on hand, or or don't have an enclosure if you don't mind it being the most, I imagine there's some high voltage going through there, but if you're comfortable steering clear of it, you might be okay without it. But you definitely need this bottom part here. Go back to the part I'm talking about here. Yeah, this part right here, that needed to be printed on a Lulzbot Taz 5, and that's a much larger print volume. I want to say it is a 12-inch square bed. Yeah, so those parts were just too large to be printed on the smaller format printers.
Let's see. Can these robots be stacked to be used in tandem?
Like you would want to attach the base of one printer of one robot to here to just create a really weird sort of tentacle? I don't think so. I think that's crazy talk.
I guess I wasn't thinking about physically stacking them, but you could also do that, yes.
I mean,
I think Did you mean to use them in parallel with each other? If you wanted to hook 2 robot arms up at the same time and run them off the same system, perhaps? We've got robots running around attacking our feet right now.
Cool. Lift this up again because I also still need to drill a center hole so that I can eventually access the underside of here so I can tighten the robot down to it. So we still need to do that. This robot is making a mess.
Yes.
Which is good.
Yes. Don't make too much of a mess. I'm tethered to a microphone, so I can't come get you.
I might still be able to get it. There's a large spade bit around here. What did I do with it?
Oh, this is pretty light. Actually, I'm wondering how heavy this thing is.
Yeah.
Actually, that's not heavy at all. It's just a few pounds.
Okay. I guess you and I have different ideas of what a heavy... That might be the heaviest electronics project I've ever built.
Oh, really? I
Yeah.
mean, it's clearly got a lot of mass, but for how it looks, I was expecting it to be heavier.
Yeah.
Yeah, it is definitely heavy duty, so it feels like a quality thing.
Let's see.
How many servo motors? So we're actually only using one servo motor for the gripper, and then the rest of these are actually stepper motors, which work a little bit differently.
Oh, bonk.
And Dash is helping us out down there. We've got our assistant helping us.
Just making sure that we have a multimeter handy.
Yes. As far as the number of stepper motors in here, I think there's 1, 2, 3, 4, 5, 6, 7. Is that 7?
I don't think there's quite that many. So 1, 2, 3,
Yeah.
4, 5, 6. So
Okay. There's
6
not one in
steppers.
here?
No.
And not in here?
No, because this rotation here is controlled by these 2 down here.
Okay, so it's offset. Okay,
yeah.
so 6 total steppers and then 1 servo motor.
Yeah, there's
Yeah.
only one. There's only one direct drive stepper, and that's in this axis right here that is driving this rotation. Which, previously mentioned, is also I think my least favorite joint in the entire robot.
You gotta wear your safety goggles.
Oh, I probably should have done that. I probably should also not just go for the large. I should probably work up my spade bits. I should definitely wear safety glasses. If I have, I do have them.
Oh, there goes my mic. Don't help too much. It's sometimes too much help can be a bit of a problem.
Of course, Cryptus Zero is asking what the model of the stepper motor is.
Oh, do you need me to hold that?
And we're through.
All right.
May have slightly damaged the workbench, but that's what workbenches are for. And we've made a mess.
How do you control the robot on the floor? You just go to letsrobot.tv, and there's various internet-controlled robots there to play with, and this particular one is named Dash. You'll need to sign up for an account in order to control.
All right. And
Oh yeah, somebody posted the link. There we go.
actually need to get to the underside of this platform now. So I'm going to take this giant robot and move it out of the way for just a moment.
Ooh.
Ooh.
All right. Oh, I got it.
Thank you.
Thanks. I think it'd be a lot of fun too if I could just like mount this on my shoulder
Yes.
and do like a Doc Ock thing. Be a little heavy,
Maybe a little bit. Well, these are M5s. I
but
need
probably worth it for an extra arm.
That's not going to work well with those M4 bolts I just punched through there. Where are my M5 lock nuts, or M4s? Here they are.
Let's see. There's a link to the robot. What model of stepper motors? I think we're using a few different stepper motors.
Yes.
I don't have the parts list in front of me. Do you happen to know?
I don't, but again, if you look in the GitHub repo that is posted on the in the description of the video, you will find it there.
All right. Yeah, they should have a parts list there for you guys to take a look. Jill, you have a YouTube channel? Yes, I do. I don't know it off the top of my head. I mean, I don't do a whole lot of YouTubing, though. I mostly stream on letsrobot.tv. And I do have a Twitch channel on twitch.tv/letsrobot. And we stream there every Friday. And we try to, anyway. And usually we do streams every Friday where we have... lately we've been having Michael Winter over, who was also on the cover of Make previous to us, and he was working on a project called AI or Die, and he's been bringing over his AI BattleBot, and he's been helping us build an actual BattleBot that's controlled by the internet hive mind. So we've been facing them off almost every Friday, and then sort of iterating on the robots like throughout the week, so we can battle again and see who's the strongest.
Yeah, that sounds like a fun project. I took it upon myself. Well, I tasked myself at the beginning of this year as a New Year's resolution, now that we're starting to get back into that part of the year again, to build a combat robot. And I haven't done that yet. So I think, at the very least, if I don't do anything else, I need to go over to... There's a makerspace over in the East Bay called Ace Monster Toys. And they do weekly... Oh, hello.
Oh, what just happened? I didn't touch anything. Are we still live?
This says it's still streaming.
Okay.
I think it hiccuped a bit.
Oh, interesting.
Yeah, everybody, it seems like it's all still streaming.
Excellent. Hello, Mr. Rad.
I'm getting the thumbs up from Hopefully It's Still Cool.
A little choppy audio.
Oh, I see.
Yeah, now it's stuttering audio-wise.
Interesting.
Are you guys getting an audio stutter?
It could be me with my Bluetooth earbuds.
Oh, okay. Oh, they're saying, yep. Yeah, they're getting a stutter.
Okay. What could that be? I mean, I'm going to stop anything, and we'll continue.
Where am I? Hanky Panky Tanky is trying to find me. I am at Make Magazine headquarters. I'm not at the office today. Hanging out here with Tyler, working on robot arms.
Yeah. Building robots.
If you need any help with the assembly, let me know. You're just securing those bolts.
That's all I'm doing right now is just
all right.
tightening this so that we have a...
Are those lock nuts?
They are.
Okay.
Yeah, they're the Nylock lock nuts.
Nice. Let me get back down to the chat.
So hopefully that stop and restart did the good things that we need to for the audio. And it sounds okay.
Tyler, don't you have an Allen tool?
I do, ish. No, I mean
We've probably got all the right things.
Yeah, our hex wrench collection here is not great, which is why I've just been kind of toughing it out with a pair of pliers, which is embarrassing to say the least, but, you know.
Sometimes the most efficient way to go is what's ever in reach.
Yeah, that's kind of what we're doing here. So the next thing we need to do is flip this over. This is going to be the tricky part, and I will need real tools for this.
Okay.
Because there's a bolt sticking. Oh, you're not seeing this because I'm on the wrong camera. There's a bolt sticking out of the bottom. This needs to go in through the top of the base that is on the underside here, and then we need to secure it with another bolt on the bottom. So I think we might need to sort of lay this whole thing on its side. Well, let's
The arm or the
arm and the
Okay.
platform. I'm going to move this out of the way so we have some room here.
So we're gonna do a multi-person operation.
Yes. And
Table request denied.
all right, so now we need to fit this into here.
Okay.
And hopefully not. Okay, the bolt slid into place, which is where it needed to go.
That's really cool. It has those bearings like all around it.
Yeah,
Like
that's
that.
kind of an interesting setup to create sort of a circular rolling platform.
Is this meant to spin 360 or does it have a limit?
It does have a limit, just because the way you can see it on the live stream here, and then I'll show it to you. The way the belt is, it fits into this circular part here, which means that eventually the motor, you know, it doesn't go through a full 360-degree rotation. Like eventually it'll just go, can't get there. See if we can see. Yeah, so it probably has something closer to like a 270-degree rotation axis, which is pretty good. We can't give robots all the freedom in the world. So yeah, I need another M8 lock nut.
Are we on the right camera?
We are on this main camera
Oh,
here.
okay, okay.
Yeah. So now I'm just seeing. Maybe I can just get at this from the underside.
Oh,
If you can.
would you like me to?
Yeah. Sort of help stabilize it. Actually, yeah, let's get this securely back on the table here. I'm going to find the right wrench for this.
Engineering excellence.
Or something like it.
Something like it. Close enough, usually. Finally, what did I do? Did I do something? Was it good? Is it bad? Was it $500 to $600 for the motors, or was there more cost than that?
I want to say $500 to $600 with the motors and the hardware. The hardware is not insignificant.
Okay, so the motors and hardware, $500 to $600, and then lots and lots of printing.
Yeah.
Untold amounts of. Did we use PLA or ABS?
This is PLA.
PLA. Okay. So don't leave this robot arm in your hot car.
No,
No. Okay.
don't do that.
I have a purpose.
What is that like?
Oh, I don't know. I guess it's nice. It's good to have one.
I don't know. Do they expect you to do things then?
Do you think it would work as a CNC? Well, you do drive it with very similar software.
I mean, yeah, you could eventually feed it G-code.
Yeah.
Do I not have
Would it be the most ideal CNC? Probably not.
No.
Yeah.
If you are interested in 3D printing and CNC, there is... I'm not going to be able to reach that.
Oh. Do you need me to hold hold it out?
All I need is an extension, but I don't think we have those.
Uh-oh.
And I dropped the lock nut. Good thing I have like 48 more of those.
Excellent.
Why is the state of our tools so deplorable?
Oh yeah, we could totally arm wrestle with this thing. We could totally... I don't know, I feel pretty intimidated arm wrestling this one. Would aluminum bars be cheaper than PLA? Well, I don't think we could print aluminum bars that easily. So I don't know if that's a totally fair comparison. It looks bigger than I thought. Haven't seen a video of anyone next to it. I think we're both just really small. Or you could be right. One of the two.
Okay, how am I going to do this?
How are you going to do it? What are we doing?
I'm
We're
trying
securing
to
the bottom?
get that this nut wrenched into place,
Okay.
but I don't have an extension that is going to fit into that gap. That's going to be tricky.
Okay.
Maybe I wonder if we can get away with not doing that for the sake of our build today.
We could just do it by hand. Maybe.
It's a nylock. It's going to fight you eventually.
Oh, okay. Oh, it is a nylock. Let's get that down there. I guess this is probably better to balance it that way. Did it try to take over the world yet? No, we're a little ways from that one. We got to do this in like multiple steps. I would start with a small territory like this table first, or the floor. I think you got to work your way up to the world.
That was properly embarrassing.
Oh, no worries. We could, somebody's suggesting that we just pour a bunch of super glue in there.
Yeah, then that's fine if we never want to take this apart again.
Yes, all of the floor. The entire thing.
Well, that's a cool noise.
Oh, I see. There is a limit.
Yeah.
Okay.
Eventually, it will just have to stop rotating. Okay. What else can I do?
What else could you do?
The only other thing I can think of is a 1/2 inch. That's a 1/4 inch drive. And if you have something that can kind of work as a screwdriver. Wait, do I have a...
Ah, yes. Live stuff.
Live internet building badly.
Eventually, it'll have a Raspberry Pi. Yes. Just get a regular nut. I guess that could be a temporary solution.
I don't know if we have any M8 regular nuts, though. But I'm going to be right back. I'm going to get something that will work kind of like a screwdriver.
All right.
And then I think we'll be at least somewhat in business.
Excellent. So, how are you guys doing today? Are you excited about this arm? This arm's really excited about you. Let's see, what other questions do we got? How about a large flathead screwdriver to fit the socket? Is that the socket on the inside under here? Burger King? Maybe. We did do that last time, didn't we? I think the last time we did a make stream, we took a robot to Burger King after the fact and let the internet order from the drive-thru. Jill, take over make. I don't know if they'd be that into that, you know. It would be
We love that idea.
Oh, you love it. Okay. I guess it sort of makes it easier for them. It's like
Tell us what to do.
deferring responsibility is, I guess, an easy thing to do.
Okay, I'm into this Jim a flathead screwdriver. I should probably plug in my microphone before I start talking. I'm into this idea of this flathead screwdriver into the base of the thing here, so I think we'll do that.
That's a good idea. Oh, wow. Good suggestion. Who was that? Who's an awesome person.
So, Jill, if you wouldn't mind, I'm going to duck under this workbench here, and if you don't mind holding this above my head, and please don't drop it on me.
Oh, the arm.
Yeah.
Okay.
So I can get underneath it. Well,
Okay.
I need you to like slide it over me, and then.
Got it.
Yeah.
Yeah. We're doing dangerous work.
This is how smart engineering happens. Whoop.
Oh, yeah.
Hopefully I'll.
So I realized I probably grabbed this in the wrong...
That's all right. I'm able to. And I am not getting any kind of engagement yet on this bolt. I need to tension it from the top.
So right now I'm trying not to drop this on Tyler's head, but I'm also trying not to let this smash on the laptop that's actually doing the streaming. This is very serious work.
The tricky part here is that. Wait. Oops.
All right, I'm going to
I've
move
dropped
this
everything.
a little bit, and then I'm going to get a better position so I can better... All right, careful, you're going to hit the laptop.
Oh, thank you for
Yeah.
minding that.
All right, slide my hand over. I can hear you talking, but I can't quite hear you.
All right.
If you guys want to ask me a question, ask it on the YouTube live channel so I can see it. Need a arm? Yes, we do. Only countless hours of printing and money went into this. No worries, Jill. Thank you for your assurance.
No. Don't lose the nut or the socket that I need in this robot crevice. Go on.
I think the arm's going to be a standalone thing for now. And we'll think about other things that we could do with it. AKA dash talking. Is that 120 hours worth of printing? Is that true?
That sounds like a number that is not unrealistic.
When I said it was like not that heavy earlier, I lied.
Hey.
Could you print with a larger nozzle? There's some kind of intricate stuff in here, and so the larger your nozzle is, I think you have to make some adjustments for that. And some of the things might not print that well if you have a lower resolution.
When I get back on top of the table, I can do a bit better indicating of like what stuff is. All right, I think that's going to be as good as it's going to get for our stream here. The socket isn't quite deep enough to reach in as well as I would have liked. So it's going to be a little bit interesting for the sake of this stream here, but we'll make do. Anyhow, nozzle diameters.
There we go.
This bottom part was printed with a 0.8 millimeter nozzle. I think everything else here was printed slowly with this standard 0.4 millimeter nozzle. And then, again, some of the other big parts like the electronics enclosure, because we don't care about how that looks, was done with a 0.8. And also this top part here was done with a 0.8 millimeter nozzle. And the reason why we did that one in 0.8 is because I realized last night that as I was doing some additional building, that the original motor for this part is supposed to be a NEMA 14 stepper motor, which is quite a bit smaller than what's in there now in NEMA 17. So executive editor of Mech Magazine, Mike Sinisi, hastily went into Tinkercad and created a new version of the part. Let's take a quick look at this part. Well, it's going to be dramatically backlit. But this part here is also printed with a 0.8 millimeter nozzle, and that's just because I needed it to get printed quickly. Because it needed to be basically printed overnight, and then so I could get it here in the morning and have it be ready. And then if you see here, it also broke because the space for the NEMA 17 weakened this a little bit, so it broke, and then hot glue to the rescue. So we'll see how that holds together. Anyhow, so we're doing things a little fast and loose today, which is, well, it's kind of our brand here on Make Live sometimes. So the next thing is to fix this onto the table. How should I mark that? And then we need to go about attaching this to, that's not the most secure thing in the world. Well,
Is there like an optimal placement for this? Is that it?
I believe the idea here is you just want to have it with, really positive tension on here.
Okay.
I'm wondering if if we had all the right drill bits, I'm wondering if I can get away with just hot gluing it into place right now. What do you think?
I guess I'd be a little concerned about the tension that we could get.
Well, I guess we could.
It would help I guess it would help to hold it in place, but
Yeah. No, we should do it right.
If you have a pin, we could just mark the holes.
I think that's the right idea. I should not be lazy. Or
Does that fit in there?
No.
Okay. But, I don't also want to create a lot of trouble. Interesting technique.
I wonder if this will work. I'm going to mark the bottom of this
I
Allen
love
wrench.
all the innovation happening right now.
That's
Wow,
just-
that totally worked.
Okay.
That's amazing.
Um,
Is this the right amount of tension? Yeah, no. Actually, I think we need more. All right, I think I've got it in a good place.
Think that's good?
Yeah.
All right. I'm going to mark these four corners in this same fashion using an Allen wrench as a Sharpie.
Jill, what am I gonna name it? I don't know. Armada? Army?
Ooh, Armada's good.
Armada?
Yeah. All right. Let's see if we actually properly marked this. We did. Only one hole, or only one mark is slightly wonky.
Yeah, you want to go with that one
Yeah.
because I pulled it out a little bit more. It's probably not quite aligned with the edges here, but good enough.
All right, and
Get a better pen.
get a better.
No.
No, it's a Sharpie. It's the best pen ever made.
We totally made that work, and that was way more efficient than having to go find another pen. Name it Jim. Jim's pretty good. I like Jim.
Jim's a good robot name.
Yes.
What's the name of that? There was a project we wrote up on Makescene. I think even featured in the magazine about a kind of sad old, and it was. I mean, it's a 3D printed robot arm like this one, but it was painted to look like green and old, like 50s industrial and kind of drab looking, and it was like a sad industrial robot arm living out its elder years, its twilight years at home, and feeling kind of useless. And I think its name was Walter.
Walter. Walter's a useless name. Sorry, Walter.
I'm sure I've known very useful people named Walter in my time. I can't remember any of them
Jim. Now. All right.
I guess it's going to be named Jim. Where was that other spade bit? There it is. Precision drilling.
Hello, Brazil. Excellent. Are we going to... Oh, time for some precision drilling.
They can't tell I'm not wearing my eye protection because I'm not on that camera.
Oh, okay. Yeah, they can't tell because the camera's not pointed at me either.
Yay!
Because there's no other way for them to know we're not wearing our safety goggles.
Yeah. All right. I'm going to double check the instructions, see what kind of screws I need for this. Really just the length.
Oh, look at that! Make with the link to the sad robot arm.
M4 by 30 is what this calls for. I have those somewhere. Anyhow, that was a neat project. Mostly it was a neat video, but okay. That's like a neat project.
Radio Shack Armatron. Interesting. Oh wait,
I remember the Radio Shack Armatron.
Oh yeah?
Yeah.
I'm not even sure what that one is.
It's a robot arm like this one that was, it was all plastic. Well, this is all plastic. It was really cheap, but it was neat. It was a robot arm.
Radio Shack.
I forgot that it was Radio Shack, though.
Armatron. Oh wait, this is totally in our office right now. It's one of these. It's actually... Oh no, you've got a different camera there. Never mind.
I do.
Yeah, the Armatron is next to my desk in the office. Somebody actually dropped one of these off for us to play with. All you people on the internet can probably go look it up, I'm sure.
You can look things up on an internet.
I heard about that. It's like this thing where you can go and look at stuff.
Like how to build a robot on
Yes.
on the internet.
Hansel, the arm. Resident sleeper? Can we see the robot? Which robot? Which robot would you like to see?
There's a robot?
Is
There's
it-
a robot.
Is it this one? Is it... Is it this one? Leaving the sawdust as dampener. Of course.
Yeah, what else is sawdust for?
Yeah, it's
Information superhighway.
exactly. You know, there's this really cool site on the internet too where you can go and you can control robots live, like this one right now on letsrobot.tv. It's pretty sweet. It's been here talking to us and helping us immensely this entire time.
Mm-hmm. couldn't bring us a 3/4 inch drive extension though, or 3/8 inch drive. That would have been really helpful. That would have been too helpful.
Yeah. No, you don't want your robots to be too helpful because otherwise they'll replace you. So they only have to be mostly helpful.
Yeah.
Yeah. Too helpful, and we just make ourselves obsolete. And I don't think we want to go through that right now.
Not yet.
Yeah, not yet.
Another
Later.
week or two.
Yes.
All right.
Let's see.
Fitting these bolts through here before I
Got some socket head screws.
go on the underside and attach them with bolts.
Oops, sorry.
That's all right.
If there's portions you would like me to do, also let me know.
My concern, because unfortunately I do have a relatively hard out at like 6, which is in 45 minutes. I'm beginning to worry how far we'll get into this before we get there. It'd be good to diversify tasks, but unfortunately a lot of these things sort of all happen serially. A lot of the things that could have happened in parallel.
Is that
It's
full
like-
duplex serial or half duplex?
Oh, I only use communication protocols. I don't understand them.
What is the smaller robot's name? It is named Dash. If you go to letsrobot.tv, it has the avatar of a fox. Because foxes are cool.
Yep. They do ridiculous things like jump and stuff their face into snow.
Oh yeah, they have a lot of cool organizational stuff here. I wish I had like one of these tool walls and a chicken. I'm totally don't have a chicken in my workshop.
Would you like a chicken in your workshop? So I'm pretty sure we can arrange it.
I don't think anyone's ever arranged a chicken for me before.
Goals. All right, Sawdust.
Oh, we got Cyber Goose with the link again. Nice. There was a lot of metal in an Armatron. Trust me.
Oh, the one I had was the body was mostly plastic. I never took it apart to look at the internals of it, so I could be fibbing, as I'm occasionally known to do.
Yeah, that was by Jeremy Lee, who also says metal pins up through most of the gears.
Okay. Like I said, I never actually bothered to take it apart. I think I at least took the grabber hand apart a couple of times.
Make a robot where all it does is squeeze a rubber chicken.
That could be this robot.
Yeah, that could be this robot. That could be this robot's entire job and purpose.
Squeeze chicken.
Just the chicken.
I had washers. Oh, wait. The washers are... The washers are in a drawer. Which is... No. Those are nuts.
Ian Liu says hi from Paraguay. I think we had a couple people from Brazil as well.
Excellent.
Excellent.
Delightful.
Indeed.
Where are my washers?
Like window washers or just washers?
The flat metal things.
Dishwashers?
The flat metal things that
Flat
distribute...
metal things. Okay.
Here they are. They're right in front of
Aha.
me. If they were actual washers, they would have distributed force.
Internet chat. So we're securing the thing. We got some washer or some.
An arm that chocks a chicken. Like, as in like wheel chocks that keeps the chicken from rolling down a hill? What a helpful robot. I should probably, before I do too much more here, actually get this belt
Oh yeah.
looped on here.
Can I? Oh, I guess I. Stetson Lee says, "Hello, I'm in USA, and now everybody's just talking about chickens." We got somebody from Barcelona. What's up? Mooney Mead. Oh, you just joined from Canada. Can you introduce yourselves? I am Jill, founder and CEO of Let'sRobot.tv, and this is Tyler with Make Magazine.
Yep.
We're collaborating on a project for an internet-controlled robot arm.
In hopes that it will make sandwiches for us.
And yes, to let you, the internet, make us sandwiches. This is the BCN 3D. Is it Moveo or Moveo?
Well, I think I've only said it aloud the first time earlier in the stream. Moveo? I think
Okay.
that's how I pronounce it.
It's the Moveo. It's an open source robot arm, and
In fact, I believe person from Barcelona, whose name I did not catch, I believe that this project is also from Barcelona. I know that it is a Spanish project, and I guess I'm making the assumption that the BCN and BCN 3D is for Barcelona. Maybe I'm making that up. Wouldn't be the first time. Oh, sorry.
no worries. Jill, what kind of sandwich? Well, that'll be up to you. It would be nice to have a variety of options.
I mean, in this dream you've had, like, what was the sandwich made?
It varies from dream to dream. Sometimes it's like bologna covered in peanut butter. Other times it's just dropped on the floor. And
I mean, I think that it's not the composition of a sandwich, but that is a likely outcome.
It's the journey. It's the journey of the making of the sandwich and the journey of this whatever it is to my mouth. Those are the things that matter in life. TrueTech says, "Oh, I downloaded that ARM from Thingiverse. Excellent."
I would advise you, if you downloaded it from Thingiverse, to look at the Git repo that's posted on the in the description of this video, or if you look at the project, from the Thingiverse page, because the Thingiverse version of it is missing some files. It is missing some of the parts.
Oh, really?
Yeah.
Oh, interesting.
Some of the little bits, like the belt tensioners and things like that, you will be missing, and you will be sad. But yeah, download the Git repo, and you'll find all that. You'll not only find all the STL files, but also all the CAD files, so you can make your own changes.
Ooh, this thing scrolls really fast.
If that's the sort of thing you like to do with your time.
Andrew Wierzinski says, "Hello from Claude, Sylvania." Interesting.
Is that a place? I don't know that that's a place.
Hi from Makerspace, Thailand.
Cool.
Hello, Infinati.
All right. I think we have at least two of the key tension points here, where we've got two corners down.
Okay, awesome.
So I think you don't need to hold it quite as robustly.
Look at that. We can simulate turning now. Yes. All right. Let's see. Does it make tacos better than sandwiches? I don't know. I think that's something we'll have to test and measure, and yeah, we'll have to study the results of each of these tests very thoroughly to make that determination.
I think we also need to determine the scope of this. I mean, how much food prep will we need to do before? Like, do we need to pre-slice pickles for it?
Yeah, I don't know if we want the internet slicing pickles. But do we need them sliced? Honestly?
Or just, you know, the whole pickle in the... Well, I'd eat that. Maybe not everybody would.
Let's see. Moody Mead says, I'm studying robotics, and I love it. It's fun, and I learn a lot, and with you too. Aw, thanks.
Aw.
Let's see. Gustavo Delfino says, can you make a sandwich with one hand? To which I would say, can you?
I'm gonna... What are the... I have to believe it's possible, because I'm sure there are people that are missing limbs that can still make a sandwich, because they need to enjoy sandwiches. But now I'm trying to think of the process, like how you'd go about, like, the most important sandwich you can make, peanut butter and jelly sandwich. Although I just recently understood that only people in the U.S. think that those are vital. Nobody outside of the U.S. thinks, everybody else thinks we're crazy. I think you're crazy if you've never had one.
All right, we got a robot stuck.
Oh, yes. You can't climb that, but I commend you for trying. But then I remembered going on a motorcycle with a ride with a friend of mine, and we stopped, and he ordered a peanut butter and jelly sandwich. And then when he finished eating it, he beamed with pride and then announced, that was the first peanut butter and jelly sandwich I've ever had. And none of us could believe it. Anyhow, I'm trying to think of how you would stabilize the bread as you put peanut butter on it in the making of a peanut butter and jelly sandwich with one hand.
Oh, we can make a bread stabilizer, I'm sure.
I mean, maybe you could use this robot as a CNC to make sort of like a cutting board with a bread-shaped indentation to like secure the bread in place, maybe with a vacuum attachment.
Oh man, this looks great.
You could
Edwin Sepulveda says, it looks great. How many filaments did you spin? Failed prints? How much time did it take? I'm actually curious about the amount of spools we had to use myself.
I want to say, of the parts I printed here, which the largest parts were not, I want to say I used maybe 6 or 7 spools of filament in total. For all the black parts, I should say. So printing up things like this part, these parts here, all of this, the base, and then the yellow detail parts because I wanted to make them look cool. Yeah, around 6 or 7 spools in total. Of the parts that were printed here, I believe that this bottom part here...
It's basically a whole spool.
I think is an entire spool of filament, or nearly, like maybe 70% of a spool of filament. So, it's not an insignificant amount of printing. Okay, well, everything is mechanically secure now.
All right.
I guess we should try and think about building electronics now, which means
Ooh.
I need to read instructions.
Oh, I could have been doing a little bit of that
Oh, yes.
at that time.
I'm bad at delegating tasks.
It's all right.
Okay.
We've learned that Tyler works in cereal.
We can look at the instructions together. So this is, we've got these stepper drivers, of which I have 6 of them in total.
Ooh.
For all of our steppers.
Oh, we should have probably planned where our enclosure was going to go.
I was thinking maybe it could go kind of here-ish.
Oh, yeah?
Because, some of these we might need to solder additional wiring extensions onto them.
So is the arm meant to reach... Oh, I thought the arm was supposed to play with the platform area. Here is... That's all right.
We can, maybe the enclosure can go here. That works.
Oh, sure, yeah.
Yes, that can work.
I forgot about the enclosure.
Yeah. Anyhow, now we have the stepper driver, which is this guy right here, and then I need to understand, based on this diagram, the dip switches. That will help me understand which direction is which.
So just to cover a couple of the questions that I saw, we saw how much did the whole thing cost, how many stepper motors are there. So the actual electronics and motors, there's about $600 worth of parts. There are 6 stepper motors, 2 of which are very big, and then we have 1 servo motor that drives the servo there. Greetings from Turkey. Hello, Sirhat, Kakmak. Let's see, Mooney Mead says, tomorrow I have an examination of robot movements, and I want to know if you can give me tips or suggestions. I would appreciate it very much. Thank you. What sort of like motion problems are you trying to, will they be asking on this examination? Is this like kinematics? Is it control systems? Those sorts of things? Is it just a simple control?
I don't even
PWM?
know. I don't even know what these questions are. This is why we brought a robot expert. So it doesn't. It goes more than 270 degrees. It's probably pretty close to 360, but yeah, there's a gap here in where the belt is. So it does go almost a complete 360 degrees. I'd say it's probably actually, I think you may be right. It may be 270. Ah! Oh no!
Arr.
Curve smash.
Yeah, you got to be careful. Make sure it's straight up. Can I do anything with the things?
Yeah. We have more stepper motors, and then I'm also figuring that we'll need to do our own power routing.
Yeah, how is our wire management on this thing supposed to work? Are there already things?
It doesn't seem like it really has much for wire management, although
Okay.
it has, there's these, point them out on the camera so you can see them on the live stream. There's these, little channels here that you see on some of the parts that look like like originally they were channels for zip ties that I wonder were a older version of securing the parts together. Instead, the parts are now secured using nuts and bolts to secure them. But those may have originally been I suppose those could be used now for wire management.
Yeah.
You can also just use zip ties zip ties make for great wire management in general.
See, so we'll have to make some extensions.
Yeah, we'll probably need to solder up some additional wiring to make this truly useful.
Let's see here. Then we got that one, and this one doesn't even have the thing in it. And then you have more of those.
I probably should be, instead of fussing about here, get on with soldering extensions onto here.
Well, this one pops out.
It's true, yeah.
Oh, yeah, we probably do want extensions, at least for finale, or for when we do the final assembly.
Yeah.
I have these really good things at the office. They're just like these little joints that you stick both ends of the wire in, and it has a little bit of solder in the middle, and you just hot gun it.
Wow.
And then it just sticks them together.
I want to know about these.
They're pretty cool. They're mostly for, they're meant to be for creating, secure under, if you're exposing your wires to water. So they're supposed to be like a watertight solution for soldering, but
Yeah.
it works just really well in general, and it's pretty cheap. And it's also a lot faster.
Yeah, that's the part I'm really interested in. But in the meantime,
So I can help you strip some of the ends on these wires so we can expose them enough for...
yeah, and I mean the other thing that we have here is yeah. So a lot of these are already exposed. I wish we had 2 soldering irons here. And then we'll eventually be learning how to connect that servo as well, because we have 6 stepper drivers.
Oh yeah, I have a bunch of servo extension wires at the office too.
Oh, sorry, Dash. And then,
Do you have more wire?
yes,
Okay.
the other concern I have is that we have this.
Oh, that's quite a board.
It's this board is known. This may be our roadblock. I've mentioned previously that I'm not a big fan of the bill of materials because it leaves some details out, such as, well, it did tell me to purchase this board, which is the ramps board, which, if you have built your own 3D printer, you've no doubt encountered this board. It is involved in, or 3D printer or any other kind of CNC board or CNC machine, where it's a sort of, I don't know exactly what it does, but it helps do some of the translation between the output from the Arduino to this guy.
All right.
And but what, and, you know, we see we have all these different X, Y, Z, E0, E1 connectors, but we don't have that wiring.
You don't have... Oh, you don't have the...
No.
Okay, I do.
Okay.
Yeah.
We will probably need that in the future,
Okay.
but not in the present. So
Yeah.
we may not be able to get too far with this anyhow, because we don't have that wiring.
Okay.
Because I did not... The bill of materials did not include it.
Yeah, that's interesting.
Yeah.
So,
Yeah, 'cause
okay,
those
so
are those
there's
are
your
basically
wire.
just little JST wires. JST.
Yeah, I have
not
the
even-
I
not
have
even
the thing. Yeah, the heads that you crimp on for these connectors. I have them at my office. Yeah, I forget what exactly they're called. Oh wow! Every single one of these motors has. It looks like an adjustable voltage. That's interesting.
All right. What am I doing?
I don't know. What are we doing?
The next part is I need to.
So we're gonna do some. Okay.
Well, I was going to go ahead and start soldering on extensions onto these motor wires, but I'm wondering what the purpose of that is. If we don't have the wiring to connect it to the ramps board in the first place, we could look further into the instructions and see if there's more useful things we can do in the time that we have left on this stream. So that's how you wire up the motors to these, and then we have these. Make sure I don't step on Dash here.
Oh, there's another 3D printed part.
Yeah, there's. I had to split it into 2 separate pieces, but here this is just a mounting plate for all of the stepper drivers. If you see in the instructions here, that everything is kind of mounted all in a row. Let's use that terminology. Get back to the instructions there. Then you can mount all of that stuff into place.
So these don't come with the wires. That's
They
interesting.
don't. And then it goes straight into the
Oh.
Arduino IDE.
So what is this for then? Oh, this goes into the stepper motor itself.
Yeah, that's
okay.
that's the connector for these big NEMA 23 steppers.
Okay.
And then it just assumes that you know everything.
Well, of course,
And then you draw the rest of the owl.
because you wouldn't be downloading an open source robot arm unless you knew everything.
Yeah. So I'm wondering if there's that much more that we can practically do here. I mean, I guess I could attach all of these stepper drivers to these mounting plates, but
Yeah, we wouldn't even be able to test this today if we don't have those connectors.
no, there's very little we can do today. That's frustrating. So learn from our mistakes when you're building this project. Be wary with its bill of materials, because it will beguile you and confuse you.
Yeah, I wonder if there's a more complete list somewhere that we missed.
Or something that explains a little bit better of like what some of the hardware is, and not catch me up with things like that NEMA 14 stepper motor that surprised me yesterday. Well, that's really going to put a hitch in things. Now I wish I'd done more of the assembly of this robot live, but you know, that's cool. We talked about it a whole bunch.
Let's see. Oh, man, it scrolls so fast. Let's see.
Hi there. How's it going down there? Do you have a bunch of wires? Well, you do have a bunch of wires, but you need all of them.
I guess they're trying to estimate how much printing the printing cost actually was. You can't get Burger King if you don't finish.
Well,
That sucks.
shoot.
Yeah.
Then there's no Burger
I was
King.
really looking forward to Burger King after this.
Well,
Darn.
we can all get our Burger King someday.
Disassemble it.
Yeah. No. No, we're not going to do that. Well, I hate for that to be the end of this, but I'm not sure much more we can do without the wiring to actually make this thing start running. That's a really frustrating way to end.
Yeah, no worries. This happens to me all the time
Yeah.
because I do a lot of live builds, and then it's always you always think you have everything, and then once you get going, there's just that one thing, and it happens to be the thing that you have to order from China, and then it takes 3 weeks to get here.
You're so much smarter with how you do your live stream, where you don't actually promise people anything. You just promise people you're going to do a live build.
Yeah, that's true. I don't.
And by order from China, you mean order from DigiKey.
Yes. Sorry.
Yeah, of course, it ordered from DigiKey, which is our good friends that make this streaming series possible and put up with us doing things like running into problems like, oh, we don't have all the wiring to make this work. Oops. Yikes. That's frustrating.
It happens.
It does. It does.
But you know what the cool thing is this is actually a two-parter.
Yes, there will be more. Because tune in next month when we are going to take this robot arm that will be more complete than it is now and then connect it to the internet so that you can drive it and make us a sandwich? Or maybe...
It'll be a surprise.
Yeah.
It'll be a surprise.
We will have a variety of tools and implements that you can grab, and we'll probably even give it better grip than it has now, because right now it's just smooth PLA plastic that will something that will give it a better grip.
Trust me, I'm an engineer says all living robots stayed living and all dead robots stayed dead. That's better than the last stream. Yes.
That sounds like a learned experience. I don't know what that's referring to.
Oh no, the last time I was here, one of my robots rolled off the table.
That's right.
Yeah, because we made this mode called table mode where the robot just pivots in place, but it was able to spin enough to where it was off center just a little bit every spin, and it spun itself off the table when we weren't looking and died.
Which one was that?
Grabitha. That was Grabitha.
Oh, Grabitha.
Yeah.
She was my favorite. Is she back together again?
She will be soon. I did actually every I've made some big changes to her already, and then I ordered some more parts that will keep the wheels from going sideways, and that causes it to break easy. So once I get those in the mail from DigiKey, I can fix Grabitha.
Excellent. Well, again, we want to thank DigiKey, where you can buy all these parts and lots of other things, for making this series possible. They're wonderful to work with, and are very understanding when we don't quite complete the build at the end, and with the sincere promise that we will do so in the future, which will be coming in at Stream in the future. For anybody who doesn't know where or what we've been on about with the Let's Robot TV platform, where can people learn more about what you do and what Let's Robot TV is?
Oh, sure, yeah. So I am founder and CEO of Let's Robot.tv. It is a platform for anyone to allow anyone in the world to control robots online. So anybody can make and build a robot to go on Let's Robot.tv. It's sort of like live streaming for robots or Twitch for robots, so you can make any sort of robot. You can add a robot arm like this. We have Dash rolling around on the floor. People have added claw machines and music machines. Like there's robots that draw, there's robots that vacuum, there's robots that mow lawns, robots that play with cats.
Has anybody made a robot that does laundry? That's been my dream.
Not yet, but it can be done.
Okay.
Yeah.
I think that's the future we need.
Excellent.
Yes. Delightful.
The internet will do our laundry. Or 5 robots.
If you are interested in 3D printing, please make sure to not miss the Make Volume 66, which is our annual digital and desktop fabrication guide. I believe if you're a subscriber to Make Magazine, you should be getting it in the mail very soon. If you are not a subscriber, keep an eye out for it on newsstands in the next week or so. It's where we do our in-depth review of all of the year's best 3D printers. And in addition, we've been diversifying a little bit more over the last few years. CNC machines, laser cutters, vinyl cutters, and now we're adding water jets, now that those are starting to get cheap enough for you to have in your home workshop or makerspace workshop or things like that, and a few other machines like that. So be on the lookout for that. It's the most fun we have making an issue every year. By most fun, it's also the one that we probably put the most amount of work into. We're really proud of it, and we hope you'll check it out. And in the meantime, thank you very much for joining. Thanks for your patience with our shortcomings on this one. We had fun. We hope you had fun, and we will see you very soon. Take care. Bye-bye.
Bye.
Now remember what I told you.
Yeah, don't make eye contact. He takes it as a personal challenge.
Hello? Pat?
Yes? Can I get a,
He'll take a Raspberry Pi 3.
No pie for you!
Told you. Hey, but I did hear this new deli. I can go pick up the sandwiches.
No!
Don't be held hostage by the board. Go to digikey.com to find thousands of boards in stock, all ready for immediate shipment.